Okay, question 10. The function f is defined by f of x is equal to 4 plus 3 to the minus x, where x is an element of the reals. Using set notation, we want to state the range of f. So, if you're playing along with the mark scheme, there is actually a bit of a mistake here. In the mark scheme, they use x for the range, which is wrong. It should be f of x. The range is the values that the function can take for the given allowed values of x. So, let's think about what happens here then. So, x can be any real number from minus infinity to positive infinity. So let's think about what's going to happen to that 3 to the minus x term. So as x tends to positive infinity, 3 to the minus x is going to tend to 0. Now, what that means then is that 4 plus 3 to the minus x, well, if 3 to the minus x is tending to 0, 4 plus 3 to the minus x is tending to 4. Now let's see what happens as x goes the other way. So as x tends to minus infinity, well, 3 to the minus x, if x is negative, 3 to the minus x is, well, minus x will be positive. So setting 3 to a bigger and bigger and bigger positive power is going to send it off to infinity. So 3 to the minus x will tend to infinity. So 4 add 3 to the minus x. It's going to tend to infinity. So we know then, if we were to sketch the function, let's just do this up here somewhere, then there's going to be an asymptote at y equals 4, or f of x equals 4. So, as x tends to negative infinity, the graph tends to infinity, and as we come along the positives, something like that is going to happen. And we can actually label the y-intercept as well. We know there, x is equal to 0, so 3 to the minus 0 is 1. So there, the value of the function is 4 plus 1, which would be 5. So all of this is bonus information. What we do now know is that the range is anything greater than 4. So the range in set notation is f of x such that f of x is greater than 4, and we also need to say that f of x would be an element of the reals. Cool. Okay, then for 10 part B, we're told the inverse of f is f minus 1. And using set notation, we want to state the domain of f minus 1. So the domain of a function are, or is the values that x is allowed to take. So the values of x that we are allowed to put into the function. Now the domain of an inverse function is the range of the original function, but instead of it now being f of x, it's x. So the domain of f minus 1 is x, such that x is greater than 4. And again, we also need to say that x is an element of the reals. Cool. Okay, and now we want to find an expression for f minus 1 of x. So, we're going to start by saying f is equal to 4 add 3 to the minus x. Now we want to make x the subject of this formula, first of all. So, if we take away the 4, we can get f minus 4 is 3 to the minus x. Now to get the minus x down, we need to take the logarithms of both sides. Now it's going to be log base 3, because on the right our base is 3. So log base 3 of f minus 4 is equal to minus x. So we get, if we multiply both sides by minus 1, minus log base 3 of f minus 4 is equal to x. And now the final step is to swap f and x, and f becomes f inverse. And therefore, f inverse is equal to minus log base 3 of x minus 4. Awesome. Good done. Okay, then for part C, we are told the function g is defined by g of x is 5 minus root x, where x is an element of the reals such that x is greater than 0. We want to find an expression for the composite function g(f) of x. So, I prefer to use this notation, g of f of x. So we're putting the f function into the g function. So, in g, wherever there is an x, it's gonna become 4 add 3 minus x. So g(f) of x is going to be 5 minus the square root of 4 add 3 to the minus x. Cool. Okay, and then we want to solve the equation g(f) of x is equal to 2, giving our answer in an exact form. So if g(f) of x is equal to 2, that means this guy that we just found up here is equal to 2. So we are setting 5 minus root 4 add 3 to the minus x equal to 2. Right, let's subtract 2, which is going to give us 3, and add the square root. So we're going to get 3 is equal to root 4 plus 3 to the minus x. Now let's undo the square root. So square both sides. That's going to give us 9 is equal to 4 add 3 to the minus x. Take the 4, so we get 5 is 3 to the minus x. Now again we need to take the log on both sides, and again it's log base 3. So we're going to get log base 3 of 5 is equal to minus x. Therefore, x is equal to minus log base 3 of 5. Good times. Question done.